let's look at some questions from our Unit 3 Trig Graphs and Equations test review. This first question, we're trying to match trig functions that have the same values. And this question really is about reference angles. So A, here, cosine of 37 degrees. 37 degrees is, of course, a first quadrant angle, which means it's going to be our reference angle, 37 degrees. And so in the first quadrant, I know that cosine is positive. And so if I'm going to find a match, I want to think of another quadrant where cosine is positive. And that, of course, would be in quadrant 4. So the angle that's going to have the same cosine as 37 degrees is going to be the same angle of 37 degrees down into quadrant 4. And so the angle that I need to figure out is this one. So of course we're going to do that by subtracting 37 from 360. And if we do that, we get 323 degrees. And so that means that answer choice A is going to match with choice E here, cosine of 323 degrees. Now out of these 8 choices here, we only have 2 matches. So I'm going to go ahead and look for the next match. If you notice my cosine choices that are left, cosine 233 and cosine 217, both of those angles are actually in the same quadrant. They're both in quadrant 3. And so there's no way that those two are going to match each other because they're different angles in the same quadrant. And they won't match either of the other cosine angles that we've already used because in quadrant 3 cosine is negative. And so these have no match. Let's talk about sine 143. So 143, that angle is over here in quadrant 2. That's 143 degrees. And so if we're going to find another angle that would have the same sign, first thing we need to do is find the reference angle, which would be this little angle right here. So to find that, we're going to subtract 180 minus 143. And if we do that, we get 37 degrees. That's our reference angle. So then, since 143 is in quadrant 2, and we're considering the sine value, well, in quadrant 2, sine is positive. And so I want to figure out what other quadrant has a positive sine value. That, of course, would be in quadrant 1. And so sine of 143 is going to match this 37 degree angle in quadrant 1, which, of course, is this G, sine of 37 degrees. All right, let's go ahead and move on to the next question. Here in question number 2, if x is between 0 and 360 degrees, what are the solutions to 2 secant x plus 10 equal to 6? Oops, sorry about that. 2 secant x plus 10 equals 6. So first thing I want to do is solve for secant. I'm going to subtract 10 from both sides. 2 secant x is equal to negative 4. And then we're going to divide by 2. And I get that secant x is equal to negative 2. Now at this point, we've got to kind of make a little change here. I don't have a calculator. And so my only options for finding the answer here are to find answers on the unit circle. But secant values, we don't know those on the unit circle. What we know are sine and cosine. So remember that secant goes with the cosine function. They are reciprocals of each other. And because of that, if secant x is equal to negative 2, or I could consider this negative 2 over 1, then we're going to say that cosine x is equal to the reciprocal negative 1 over 2. Now we have a unit circle value. Cosine x equals negative 1 over 2. I know that cosine has the value of 1/2 at the pi over 3 angle. However, I notice here that cosine is negative, and so I need to think in which quadrants is cosine negative. That, of course, would be quadrants 2 and 3. So that means that I want the pi over 3 angle that's in quadrant 2. That would be 2 pi over 3. And I want the pi over 3 angle that's in quadrant 3, which would be 4 pi over 3. And so those are the two answers, the two solutions to this equation. All right, next question. We're asked to sketch the graph for 2 secant x. Now with these graphs for secant and cosecant, what I like to do is first sketch the reciprocal graph and then build the secant or cosecant graph based on that. So my reciprocal function for secant is again cosine. And so what we're going to do here is start out by graphing y equals 2 cosine x. So cosine, let's see, pi, I'll make this, actually I'll make that pi, 2 pi, and this 2 cosine x, that's going to have an amplitude of 2. That's the only change here is an amplitude. So we're going to go up to 2 and down to -2. And so this cosine graph is going to look like this. Starting at 0, completing the full cycle by 2 pi, because that's my period, bottoming out here at -2 when x is equal to pi. And then if we wanted to extend it a little bit, I'll add a little bit over there. So when I start to draw the secant graph, remember that we're taking the reciprocal of this graph, and the first thing that I want to think about are the zeros, where cosine crosses the x-axis at these zeros. If I take the reciprocal of 0, I get 1 over 0, which of course is undefined because you can't divide by 0. And so that means at those places, wherever cosine equals 0, secant is going to have an asymptote because secant is going to be undefined. And then once we get in the asymptotes, the secant graph is just going to build off the cosine graph like this. All the minimums and maximum points on cosine, they're shared on cosecant. And then the graph just opens up or down approaching the asymptotes. So the blue part of the graph that's showing here, that's the graph for 2 secant x. Let's look at one more question for this video. Whoops, I don't know what happened there. Here we go. On this one, we've got a graph of a sinusoidal function, either sine or cosine, and we're asked to write 2 equations, one sine and one cosine. So in order to write those equations, we're going to use the form y equals a sine of b times x minus c plus d. We're going to use this format, which means I need to figure out my a, b, c, and d for each one. Now I'm going to save the c for last because the c, that's the only value that changes based on whether or not you're writing a sine equation or a cosine equation. So before we do that, let's figure out our a, b, and d. I like to start on these graphs by identifying the midline, because if I know where the midline is, that helps me figure out amplitude, and the midline gives me my d value. So if I look here in the graph, my high points are up here at 5, and the low points are at -3. So 5 minus -3 is 8, and if I divide 8 in half, I get 4. So that means my midline is going to be 4 away from each of these values. So I can count down from 5, 1, 2, 3, 4. Or I could have counted up from -3, 1, 2, 3, 4. Either way, I end up with a midline right here at +1. And so that means that my D is equal to 1. My A, which is my amplitude, is 4, that distance that we counted from the midline to either the highest point or the lowest point. So now let's figure out B. Remember that to find B, it's going to be equal to 2 pi divided by the period. So I need to look at this graph and figure out the period. And I think one of the easier ways to figure out the period is to look for a full cycle of cosine. Basically, I'm seeing a high point here, starting cosine, and then we go down and come back up to the same place. That's my period. So I can see here that my period is 2 squares between these two points. I've got 2 squares between them. Each square is pi over 4. Those are my units labeled there on the x-axis. So if I have 2 pi over 4 squares, that's going to be pi over 2. So I need to do 2 pi divided by pi over 2, because pi over 2 is my period. And then since we're dividing by a fraction, we're going to multiply by the reciprocal. So 2 pi times the reciprocal of pi over 2, which would be 2 over pi. And so we get, 4 pi over pi. And our pi's cancel out, and we're left with 4. So kind of ran out of room up there. Let me just write this again down here. B is equal to 4. So I have my A is 4, my B is also 4, and the D. So let's write our equations. Let's do a sine equation first. So y is equal to 4 sine of 4 times x minus something, we don't know yet, plus 1. So I've plugged in my A, B, and D. Let's figure out what my C value is. In order to figure this out, I'm looking at the graph up here and looking for a starting place for sine. Remember that sine starts in the middle, on the midline. And so let me erase this right here. So I could choose this point right here to be a starting point for a sine graph. That would be a sine graph. So my C value is going to be the x coordinate that is associated with this point right here, the x coordinate down here. And that is halfway between the 0 and pi over 4. So that x coordinate would be pi over 8. Now there are other places that you could have chosen to start the sine graph. We could pick this point, we could pick this point, although at this one it would be a negative sine graph because the graph is going down from that point. But there's lots of other correct answers here. Okay, next up, let's do a cosine equation. I'm going to erase my little sine work there. There's my midline back. All right, so cosine equations, those of course start at the top. Cosine starts at the top. So I could pick this point right here as the starting place for one cycle of cosine. And so my C value is going to be the x coordinate that is associated with that point. And that point is at pi over 4. So for my cosine equation, y is equal to 4 cosine of 4 times x. This is the only thing that's different, minus pi over 4 plus 1.